Hello everyone, I'm sorry that I had to be gone today, but if you would please have out, yesterday we were working on 4.3, writing equations in point slope form, so have out day 8, section 4.3. Answers are going to be right here. Let's see if I can get them right there. So I'll put this on full screen. And then if you need to, let's pause the video, give everyone about a minute or so to grade their homework. And then on Monday, when I get back, I can look at both this one and then the homework that would be for today. So right now, I'm just giving you a chance to look at the answers and grade your work. So if you need to, you can pause the video now and have everybody get a chance to actually grade their questions, mark their mistakes, and then have questions ready for Monday. Okay, welcome back. Hopefully everyone had a chance to correct their homework. Then if you would please try the following warm-up questions at the bottom of that homework. First question is to find the slope of the line that passes through the points 2, -1 and 0, 4. And then the second and third questions are actually on something called an arithmetic sequence. We skipped this section in chapter 3, but it's actually very much connected to how we talk about point slope form. So give questions 2 and 3 a try. It's a table right now where I've said the first term has a value of 4, the second term has a value of 9, third 14, then the fourth term 19. The first question, just to ease you into it, is just to find the next 3 values in the table. Then the third question asks you to extend that thinking and tell me what the nth term would be. So for example, if I kept going on and on and on, I don't want to know what the 8th or the 9th or the 10th. I want to be able to know what the nth term would be. So I could tell you any n value, you'd be able to quickly tell me what the value in that table would be. Like for example, once you have that equation potentially, use it to tell me what the 50th term in this sequence would be. So give those questions a try. Let's give everyone a chance, maybe 2 minutes to try this warm-up question. So pause video now, give everyone a chance for 2 minutes to try it, and then we will get started. So pause video now, please. Okay, welcome back. Let's do the first one real quick. First one's just a brief review. Make sure that we are able to calculate slopes. The slope is equal to 4 minus a -1 because it's my rise, which is my change in y, divided by my run, which is my change in x. 0 minus 2. If you need to, label your points. This is x1, y1, x2, y2. 4 minus a -1 is a 5. 0 minus a 2 is a -2. So I would say that my slope is up 5, left 2. My rise is 5. My run is -2. Second question. This is, like I said, this is called an arithmetic sequence. The reason that it's an arithmetic sequence, as you noticed probably as you filled in the next few values in the table, is what was the pattern? It was constantly adding 5. So anytime you're constantly adding or subtracting a number in a pattern, it's called an arithmetic sequence. So the next value would have been, if I add 5 every time, add 5, add 5, add 5. If I continue that, this would be 24, and then 29, and 34. Okay, that was just the easy win. My actual real question was, can you tell me an equation that would allow me to then pick any term in the sequence, and you could easily calculate what the value of that term would be? So the way to think about this is kind of translate it the same way that we translated Bruin point slope form. If I think about this, it looks like this. I would say the value of this sequence starts off at 4. Value is 4. Looks like that. And then what are we doing? We are adding 5. We are adding 5 for every term. Let's say it's the nth term, for every term past the first one. Okay, so I'm going to retranslate. The value is equal to 4 plus 5 for every one past 1, because this is like, really, this is like a point right here. This is a point 1, 4. If I wrote it in Bruin point slope form, it would be the value is 4 plus 5 for every n, for every term past the next one, past the prior one, in this case the first one. So it looks like value equals 4 plus 5 times the quantity n minus 1. If you actually simplify this, what you get is you would get 4 plus, if I distribute here, distribute, I get 5n minus 5. If I simplify by combining my like terms, I end up with 4 minus a 5 is going to be a negative 1 plus 5n. Either one of these are valid ways to write the what's called the general equation for the arithmetic sequence. I actually see it here. If I go to this table, I'm going to go back up here and erase these things. If I slide all these values over 1 right here, and I ask myself what would have been the 0th term? Well, if this way is adding 5, the other way is subtracting 5, hey, it's negative 1. There is my y-intercept, 0, negative 1, and what's the pattern in the table? It's add 5, and that's where I see it right here, negative 1 plus 5n. So there's two ways to view it. I can either kind of view it using slope-intercept form if I thought about the 0 term, or I could think about it in point slope. Last question was what would be the value of the 50th term? So all I need to do then is plug in 50 for n. Let's do it for this guy. This one's simplified. So the value would equal negative 1 plus 5 times 50, which is going to be negative 1 plus 250. So the value of the 50th term would have been 249. There you go. That's what's called an arithmetic sequence. If you're interested in learning a little bit more about that, that's about really all you need to know as far as this class is concerned. But there's a little bit more of it talked about in Chapter 3. There's a whole section on arithmetic sequence. Okay. Moving forward, though, if you would please have out your notes for day 4.2. It's on writing linear equations in slope-intercept form, but we're doing it algebraically. Okay. So I'll give you a second. If you need to, you can pause the video, make sure everyone's set. If we're good to go, then we can just roll. Okay. So first question is, how does our Bruin point slope form change when we start with an x-coordinate of 0? And the reason I'm asking that is because an x-coordinate of 0 implies that we have a y-intercept. Okay, so example. Let's say I start at a y-coordinate of negative 4, right down here. If I need to graph it, I can, and go up 2 for every x past 0. Up 2 for every x past 0. Okay, so it would look like that if I graphed it. If I actually wrote the equation, though, it looks like this. If I did in Bruin point slope form, it'd be y is negative 4 plus 2 for every x past 0. Okay. If I simplify this by distributing that 2, I actually am just going to end up with y equals negative 4 plus 2 times x, because 2 times the 0 when I distribute is 0. And what I end up with is my intercept slope form, or they also call it slope intercept, just depending on which way you write it. You could also have written this as y equals 2x minus 4, and the reason that most mathematicians write the x first is because you usually write the highest power. This is an x to the first power, this doesn't have an x. So either way you write it, you'd be correct. And what I actually see is I get slope intercept form. I get y equals mx plus b. So if I simplify intercept slope form, I actually get, or if I simplify Bruin point slope form, I get slope intercept. Okay, that's the kind of lead in. Either way you write it is totally fine. You can write it as y equals b plus mx or y equals mx plus b. What we just found is when you simplify point slope form, you get slope intercept. Okay. Well, what happens if you look at this in terms of function notation? Like instead of writing y equals mx plus b, I did it in function notation. Well, nothing changes. It's just that I've given the graph a more specific name. I called it f. I could have even called it g. It could be g of x equals b plus mx, or I could even write it as mx plus b. It doesn't matter which you write first. You just need to know that the number next to the x is the slope, and the value all by itself is always your y-intercept. Okay? So it doesn't matter if you write it in function notation or if you write it with a y. When you simplify point slope form, you will get slope intercept form. Okay? What if you're just given the slope and the y-intercept? Write an equation of the line with a slope of negative 2 and a y of 5. So if I wrote this down, it would be a slope of negative 2 and a y-intercept of 5. I could just substitute this in to my slope-intercept form. Y is equal to 5 minus 2x, and I'm done. I could also write this as y equals negative 2x plus 5. So if you're just given the information verbally, you can easily write the equation for the line. You start at a y-coordinate of 5 and go down to right 1, that's my slope, for every interval past x coordinate of 0. That would be point slope form. Y equals 5 minus 2 for every x past 0. If I simplify that, I just get y equals 5 minus 2x. You don't need to do all that. If you can just simply see that it's y equals negative 2x plus 5, that's fine. I'm just trying to interconnect all the different ways we have to represent lines. Okay? If you would, please then on the whiteboards, you give it a try. Can you write the equation in slope-intercept form? So that's y equals mx plus b, where m is the slope and b is the y-intercept, for a line that would go through the point 0, 3, and 1, 7. So you need to be able to calculate what the slope would be and pick out the y-intercept or figure out the y-intercept somehow. Okay, so if you would please pause the video, give everyone maybe a minute and a half to give this a try. After a minute and a half, everyone's had a chance. When you've got your answer, compare it with your neighbor, make sure you both agree on what the answer is, and then we'll come back and you can compare it to how I worked it through. Okay, welcome back. First thing is I need to be able to find the slope. So that's why we did the warm-up question reviewing how to calculate slopes. Slope is rise over run, y2 minus y1. y2 is 7, so 7 minus y1, which is 3, is going to be 4. Then my run, because it's rise over run, is x2 minus x1. 1 minus 0 is 1. A slope of 4 over 1 I can just simply write as 4. So I know my equations y equals 4x plus or minus something, depending on if the intercept is positive or negative for y. The y-intercept b, how am I going to find that? Oh, actually note, one of these points is a y-intercept because it has an x-coordinate of 0. So b is actually equal to 3. So my equation is y equals 4x plus 3. That's how I can write the equation for a line if I'm given 2 points and one of them happens to be the y-intercept. My first step is calculate the slope. That'll actually always be my first step. Second step is going to be somehow get the y-intercept. Okay? Moving right along. Example 2. Write the equation for a line in slope-intercept form that goes through the point 3, 1 and has a slope of 2. So first thing I need to do is figure out what the slope is. And what I'm going to do is I'm going to show 2 different ways to actually do this. You can simplify point-slope form, or you can write it in slope-intercept form and solve for b. Okay, I'll show both methods, and it doesn't matter to me which one you use. Some people really like method 1, some people really like method 2. So what I'm first going to do is try to write this in Bruin point-slope form and simplify. So I would write this as y equals 1, because that's my y is 1, and my slope is 2. So plus 2 for every x past 3. That's what Bruin point-slope form would look like for the equation of the line that goes to the point 3, 1 and has a slope of 2. But I want it in slope-intercept form. I want it in y equals mx plus b. So what I need to do is I just need to simplify this. So distribute my 2, and I get y equals 1 plus 2x minus 6. Combine my like terms of my numbers. 1 minus 6 is negative 5. So I get y equals 2x minus 5. And I'm done. The line that went through the point 3, 1 with a slope of 2 would be the equation for that line would be y equals 2x minus 5. That's method 1. Method 2 looks like this over here. It says, okay, I need the equation y equals mx plus b. I actually happen to already know what the slope is. It tells me the slope of the line is 2. So the equation of my line would look like y equals, I'll put that 2 in there for m, 2 times x plus b. The problem is I don't know what the y-intercept is, and unlike the whiteboard question you just did 2 seconds ago, this point 3, 1 is not a y-intercept. It doesn't have an x-coordinate of 0. But what I do know is this point is on that line, so I can substitute it into the equation of my line. I'm going to substitute in 3 for x because that's the x-coordinate, and I'm going to substitute 1 in for y because that's the y-coordinate of the point. So wherever I see an x in my equation, I'm going to put a 3. Wherever I see a y, I'm going to put a 1. So it looks like this. I'm going to put the 1 right there. I'm going to put the 3 right there for x. So 1 equals 2 times 3 plus b. Now I can solve for b. 1 equals 6 plus b, and to get rid of the 6, I subtract 6 from both sides. Subtract 6, subtract 6. 1 minus 6 is going to give me negative 5, and I get negative 5 equals b. Now I know my slope and I know my y-intercept, so I can write the total equation for the line as y equals 2x minus 5. And I see, oh hey, it agrees with method 1 that I did. Method 1, method 2 are just two different ways getting the exact same answer. Method 1 is take point slope form and simplify. Method 2 is to write it out as y equals mx plus b, substitute in your slope, and then solve for your y-intercept. Okay? If you would please then, on the whiteboards, this will be the last yo-yo for the day, I want you to try exactly what I just did. But I want you to try both methods at least once, so then you can choose which one you like more. So I want to know the equation for the line that goes through the point 2 comma 5 and it has a slope of negative 2. You need to try method 1 of write it in Bruin point slope or just point slope form, doesn't matter to me. Somehow write it in point slope form and simplify, and then try method 2 of writing it in slope intercept form, y equals mx plus b, substitute in your slope and the point, and then solve for b. Okay, so this will probably take, I would guess, a good 2 minutes, maybe even just a little bit more. So pause the video for at least 2 minutes, give everyone a chance to try, and then share around, turn, show with your neighbor. Make sure that you both agree on all the steps that you went through. You should get the same answer for method 1 and method 2. So that's another check that you can use on yourself. So pause the video now, come back after everyone has had a chance to try. Okay, welcome back. Let's do the first one. So I suggested maybe writing in method 1, doing Bruin point slope form and simplifying. So Bruin point slope form, it would be y equals y1 plus the slope, or minus, depending on if it's a negative, for every x past x1. I substituted my values. It would look like y is 5 to start, because that's my y-coordinate. My slope is negative 2, so I go down 2 over 1 for every x past 2. This 2 came from the fact that my x-coordinate of my point was 2. Now I just need to simplify. Distribute my negative 2. I get y equals 5 minus 2x. Negative 2 times a negative 2 is a 4, so I write plus 4. Now I combine my like terms. I have a 5 and a 4, so the equation for my line would be y equals negative 2x plus 9. There you go. I've written it in slope-intercept form. The slope of the line is negative 2, which I wanted, and the y-intercept for that line would be a positive 9. That's method 1. Method 2 looks like this. I'm going to substitute in the slope that I know. I know the slope of the line is y equals negative 2x. Now I just need to solve for b. So I substitute in the x-coordinate of the point I know, which is a 2, in for x, and 5 in for y. So it looks like 5 equals negative 2 times 2 plus b. Negative 2 times 2 is a negative 4. Add 4 to each side to solve for b, and I end up getting that b equals 9. Put the pieces together. I knew the slope was already negative 2. I just found that the y-intercept is 9, so my equation is y equals negative 2x plus 9. There you go. Method 1 and method 2 agree. Doesn't matter to me which one you use. You just need to show your work so that if you make a mistake, I can help catch that mistake and fix it for you. Okay? Perfect. Last ones that we're going to try look like this. What if they're given to you in function notation? So write an equation for the linear function f. That's just renaming the line. Instead of writing y equals mx plus b, I'm going to write it as f of x equals mx plus b, but it is the exact same thing. I've just been more specific. I've named the line f. For a line that has f of 9 equaling negative 2 and f of 4 equaling 3. Okay. The thing to remember about this is this was an x value. This was my input. This was my y value. This was an x. This is a y. So really this is just a different way of saying that I want the equation of a line that goes through the points 9, negative 2, and 4, comma 3. Okay. Well, the first thing I need to do is I need to calculate the slope. The slope had always been given to me before, but now I actually need to calculate it. So step 1 is going to be calculate your slope, and that is always going to be it. Check to see if you have your slope. Sometimes it's given to you in a graph, sometimes it's given to you orally or in writing. Sometimes you're going to need to calculate it because you have 2 points. So first step is calculate my slope. So m equals 3 minus a negative 2 divided by 4 minus 9. 3 minus a negative 2 is the same as 3 plus 2, which is a 5. 4 minus 9 is a negative 5. This one works out nice. My slope is equal to negative 1. So I know my slope. Next thing I need to do is I need to get my y-intercept. Okay, so that's step 2. I know my slope is negative 1. Now I need to get my b, my y-intercept. And there's 2 ways I can do that. I can either do it using Bruin point slope, or I can do it by solving for b by substituting in a point. So I'm going to go over here. We've already found that the slope was negative 1. Okay, and now I need to solve for b. And there's 2 ways to solve for b, just like we did. You can do Bruin point slope and simplify, or you can write it in slope intercept form and solve for b by plugging in a point. I will do both just to show it because I know we're probably a split. So first one, write it in Bruin point slope form and simplify. Question would be, which point do I use? Do I use 9 comma negative 2, or do I use the point 4 comma 3? And it doesn't matter. Because both of these points are on the line, it shouldn't matter. You should be able to use either one and you will agree on the final answer, and I'll show you that. So maybe for this method 1, I will use the point 9 comma negative 2. So I would say y is negative 2 to start. My slope is negative 1, so I go down 1 over 1 for every x past 9. Now I simplify. Distribute my negative 1. I end up with y equals negative 2 minus 1x, or you could just put minus x. Negative 1 times a negative 9 is a plus 9. Combine my like terms of 9 and negative 2 and I get a 7, so I'd say y equals negative x plus 7. And I'm done. The slope of that line is equal to a negative 1. The y-intercept is equal to 7. Now let's show method 2. I start off by writing it in slope intercept form. I want y equals mx plus b. I've already found the slope, always my step 1. Y equals negative 1x plus b. Now I substitute in a point, and it doesn't matter if I use 9 comma negative 2 or 4 comma 3. I'm going to use 4 comma 3 for this one just to show it doesn't matter. So I'm going to put 4 in for x and 3 in for y. So 3 equals negative 1 times 4 plus b. 3 equals negative 4 plus b. Add 4 to each side of your equation to get b by itself, and I end up with 7 equals b. Put it all together, y equals negative 1x, or just negative x, plus 7. And I'm done. I see that they both agree. Y equals negative x plus 7, y equals negative x plus 7. Doesn't matter which way you use, or even which point you use, because both of those points are on the line. Key things to take away. Step 1, always see if you have your slope or if you need to calculate it. Step 2 is solve for b. You can either do Bruin point slope and simplify, or write in slope intercept form and then solve for b. Just to check, I've graphed this in Desmos. Want to see if it goes to the point 9 comma negative 2 and 4 comma 3. So in Desmos, I've already typed that in, picked out my points 9 comma negative 2 right down here, and 4 comma 3, and then I typed in my equation y equals negative 1x, or you could just do, like I said, negative x plus 7, and boom, it goes perfectly through both of those points. That's it. That's all that we're working on today, is writing the equation of a line in y equals mx plus b in slope intercept form. If you were given some pieces of information, a point and a slope, or usually 2 points. The homework for today, we are on day 9 right here, so it'll be page 229, listed in your pacing guide. The presented problems on Monday will be 7 and 25, and that's it. Answers I will put up right here at the end of this video, so if you need to, you can just leave the video paused at this point. And then I will see you on Monday, and then have any questions ready for me that you might have. Thank you very much.